Well, evening all. We should be live on YouTube, all being well. I'm not going to check it. I'll assume it's all working. I'll assume that the computers are doing what they're supposed to do. So yeah, welcome. This is the first Cloud Native and Kubernetes Edinburgh meetup. As you'll no doubt notice, I'm joined by a familiar cast of characters. Hopefully to anyone that's attended other meetups in Edinburgh, you'll see that I'm joined tonight by my co-hosts Adrian, Connor and Alex. And yeah, we hope to bring some new and exciting things to the world of Cloud Native and Kubernetes in Edinburgh and beyond over the coming months and coming meetups. On the subject of which, we're going to have a bit of a roundtable discussion later on regarding format, and we're really looking for ideas from the community as to well, how we can best serve the community in Edinburgh. I know Alex has got some particularly interesting ideas around hackathons and workshops, that kind of stuff, just to mix things up a little bit. Because I think we're all probably getting a little bit bored of the same virtual meetup formats. In fact, we were just lamenting the lack of beer and pies and pizza from meetups that used to attend in person. So yeah, trying to get something different in place would be cool. So yeah, tonight, apart from me rambling for the first few minutes, we'll get started with Jürgen, who's here with us tonight to talk about scalability issues and how to overcome those in your Prometheus ecosystem. And then after that, we've got a DevOps focused talk from Cameron from ECS, who's going to introduce some GitOps related concepts using Python, Terraform, and AWS Lambda. So yeah, all pretty cool stuff. None of which is Kubernetes specific, which is also really cool. Anything else anybody wants to add?
I think we're good to go.
Cool. In that case, should we kick off with the first talk, if you're good to go, Jürgen?
Yes, sure. Let me just share the right screen and move things around a bit here. Absolutely.
Excellent. So we'll bring that up and we'll drop Husla out, and then it's over to you.
Cool. Thank you. So I think screen sharing should work. Looks good. Cool. Yeah, thanks so much for having me here. I'm happy to join you at this Cloud Native and Kubernetes meetup. My name is Jürgen. I am from Austria, from Linz. I work at a company called Dynatrace. But yeah, for today, I won't be talking about Dynatrace or the Dynatrace product at all. Instead, I will focus on Prometheus and the Prometheus ecosystem. Also, how our open source project or the open source project that I'm involved in is actually helping here to overcome some scalability issues in Prometheus ecosystems. It's all based basically on learnings and why we while we were developing our project, we kind of discovered what it can do besides its initial purpose. So I will share a little bit about this with you today. So I want to discuss some challenges that we've discovered when we talked with organizations or with individuals that are using Captain, this open source framework, and how they are using it, and what they told us, which challenges they were facing initially, and how they probably also contributed back to Captain. I will propose some solutions for those challenges that you can also use without our open source framework. So it's basically some learnings and some solutions that we can always recommend and suggest, even completely tool agnostic, I would say. And if you have some suggestions, if you have some learnings, if you have something you want to share, it would be also great if you put in the comments or just tell me. My Twitter handle is on the first slide. I will also, I think it's also on the last slide. I think you can even see it if I take a look at the other screen. You can even see it in my my tag there. So just feel free to reach out, and I'm also happy to share the links, the link to the slides afterwards. So you have the links, and you have also possibilities to reach out if you have some suggestions how you did it in your organization. So what we actually want at the very end, the goal of everything when we are dealing with Kubernetes and Prometheus and Grafana, We want to have automated dashboards. It's not so much fun to configure all these dashboards manually or to hack those dashboards together. We want to have dashboards out of the box. We want to have alerts, if possible, out of the box for all our applications and workloads running in production. Of course, we want to tweak them, but we want to have a good set of already defined alerts, so we know if something goes sideways that we will get alerted. And for this, of course, we need some monitoring. I said I work for Dynatrace, so that's a very, for us, a very prominent product in this space. But let's talk about Prometheus. So you have your Prometheus cluster. It's fetching all the metrics from the different endpoints, and you just want to have a lot of it automated, let's say. So where do we start? I want to highlight a couple of building blocks that are standard in Kubernetes environments, very basic. And then I want to highlight these challenges and propose a solution for each challenge. And I will also show you a little bit of Captain. And if time permits, I will also do a short demo, especially on the configuration parts of Prometheus and Grafana. And if you're interested, I put a link in there. So here I've blogged about this, and you can also take a look there. It's kind of a summary of this presentation. So how do we get started? We have our Prometheus cluster. We have probably a couple of managing Prometheus or Grafana, and we do have our application clusters with all our workloads in there, and we have Prometheus scraping all these metrics endpoints. And we might have a couple of those clusters, and we might have a couple of application clusters and Prometheus clusters. What I won't talk about today is how to scale Prometheus clusters. There are different solutions out there like Tanos, Victoria Metrics, and a couple of others that provide high availability setups for your Prometheus installation. And I won't tackle this. So I was just name dropping here, Tanos, Victoria Metrics, and some others. If you're interested in this part, please take a look at these projects. I will be more taking a look at how to deal with all the configuration that you need for Prometheus, for Grafana, and for all your applications. So this is the part, that's why it was called organizational scaling and not scaling from a very technical perspective. So first challenge that we have seen is using the whole Prometheus ecosystem is mostly Prometheus with all the scrape jobs and rules, the alert manager with all the alerting rules, and Grafana. That's like, I would say, the three parts that are most often used. And of course, you have to write all the configuration. So you come up with some standard configuration, and you apply this configuration to your Kubernetes cluster or to your Prometheus installation, to your Grafana, and then you're good for the first iteration. Problem is, whenever something changes. So we have seen a lot of changing configurations in production environments without having some kind of synchronization or configuration management solution. So one very, I would say, kind of an obvious thing to do here is to use some GitOps approach. Put everything that you edit, put everything into a Git repository, and only from the Git repository, you're allowed to sync it to the Kubernetes installation and to the Kubernetes cluster or Prometheus installation. So everything first has to go into a Git repository, and it's only allowed to be synchronized from the Git repository then to your installations. So in this way, there are no manual edits anymore in production or staging or whatever environments you might have. And you also have like all the different things that you know from a GitOps approach, like pull requests, like versioning, the easy possibility to roll back. So you should really not have something in production that and something different on your hard drive or something different in your Git repository, but the Git repository should be the single source of truth, and you're just applying this automatically with some kind of operator. So there are also solutions out there that are just basically syncing the Git repository with your Kubernetes clusters. That's the first part. Still, you have to come up with all these configurations. So you have to write all those configurations. And that might be a lot of work. And it will be a lot of YAML. So most of the time, scrape jobs and learning rules are usually in YAML. Dashboard configurations are usually in JSON. Of course, you can transform and vice versa. But still, it's a lot of configuration you have to write. So one good approach, and we have found a lot of different code generators out there, is to use them. Make use of those code generators. You just feed them with the data. They are built for different purposes, but I'm pretty sure you will find the one that fits your needs. A couple of them, they are linked at the end of the slides. I have a resource section, and you will find a couple of them. And you basically feed them the data, and they will come up with scrape jobs and alerting rules. A couple of them, they are based on quality standards like service level objectives, and then you can also type in the error budget and these kind of things. So you have your alerting based on those practices, which is pretty sweet. And with dashboard configurations, there's also a couple of libraries out there that you can use, and they will provide a lot of different dashboards out of the box for you. So you don't have to start writing all these configurations, just use them. Repository, don't apply directly to your installations. So still, there is one part that might be a little bit challenging, is to synchronize between those configurations. So you might feed the scrape jobs and alerting rules with different input data than the dashboard configurations, because the code generators themselves, they are not built to use all the same inputs. So for example, for the dashboard, it's probably more important to have, let's say, to have which workloads you actually have, how many services you have, where. But it maybe for your dashboards, it's not important what your alerting rules are or what your error budget is. So it just depends on which code generators you're using. They also decide which data you can feed them, obviously. So the problem might be that over time, your configurations, they drift a little bit out of sync. In the beginning, you might be able to match them. Maybe there's some manual matching needed, so that you just build small parts of the dashboards by yourself. But the more it grows, and we've seen once everything's working, organizations tend to put more workload into Kubernetes and monitor it with Prometheus, which is a great thing. But it's just there is this chance and risk that those configurations drift out of sync. And then all the other things, like everything that in Git it's not useless, but it's a little bit more challenging to use. So what we think is a nice idea is to use those SRE concepts from site reliability engineering, and use this concept and feed your code generators based on these concepts. I've mentioned already something like service level objectives. I mentioned where you can basically define an objective for your service, and you can create then the error budget, or you can create the alerting rules. You can create a couple of things with this information, and you feed this basically into the Git repository. So with this, you only have one. Let's say it's probably not standardized, but it's based on the same concepts. You have one configuration that you can feed this code generators, and then you can generate the other parts. With this, you can really define what you want. So we have now moved from the very first part where we were manually writing YAML and JSON files just to define scrape jobs and alerting and dashboards. We have moved into an abstraction, kind of a higher order language, to defining what you want to have, and then have the rest figure out how to do it. And that is basically also the idea behind Captain. Captain was not built for this initially, but we found that we have all those concepts. We have them built in already. And if you want to use them, you can just use Captain. You can use it for even more, but also for configuring and onboarding and managing your workloads in Prometheus and Grafana. So you can automate the configuration, but it also has quality gates for continuous delivery and automated operations baked in. So I will show this to you just in a sec, or I will explain a little bit more behind Captain in a second. What I want to show you is how Captain actually will do this part. So we have one file that is an SRE-based description, and we will generate the rest out of it. So we will generate some scrape jobs, some alertings, and some dashboard configurations, and everything is stored in the Git repository. And I will just show you a very short demo, and then I will basically explain what was going on in the demo behind the scenes. I thought it's maybe easier doing it this way instead of first explaining everything and then just start showing the demo, since it's quite short. So I don't want you to kind of to spoil everything that I'm doing here. So what I do have is I have a Grafana installation here. It's not nothing's going on here, so I deleted everything before, and I do have also a Captain installation. So I won't show you the Captain installation right now, but I can just show you that I have a couple of projects, I think. Captain has a CLI, so I can just ask Captain for the project that I've already onboarded. And prepare the project. And what I want to do is I configure my, monitoring environment, basically, for the project sock shop, and I have a shopping cart service onboarded there. So let me just do Captain configure monitoring. So it will configure my monitoring solution. In this case, it's Prometheus and all the other services that are interested. I'm saying interested in configuring Prometheus, which you will see in a second what I mean with this, and for which project and which service. So I will just execute this, and Captain will, the Captain CLI will send in the background, will send a cloud event to the Captain control plane that lives in our Kubernetes cluster. And from there, this cloud event will be distributed to the different services. And in my case, there is a Prometheus service and a Grafana service listening for this information. So they are now receiving this event that Prometheus should be configured for the project sock shop and the service cards. I don't do anything more here because Captain has already some configuration files stored in its Git repository that will describe what is the quality of the service, of the shopping cart service that I want to configure. Captain already knows, since I added this Prometheus service, where the Prometheus is located and how to reach it. And the same is true for Grafana. So with this, I can easily send this cloud event and distribute it to my whole Prometheus ecosystem. And if we take a look now into the dashboard, what we should see is hopefully, yeah. So I was creating the standard dashboard of Captain, and I will see there is just one dashboard in it. And I can see it just starts to put in some data. So maybe I'll go for the last 5 minutes. We see a little bit more. So I'm already seeing some data for different stages, production, staging, dev, for this shopping cart service, in my case. And I can see I have the response time, the throughput, and the error rate already. I have some predefined dashboards already. These, they come by default, they come with Captain, and you can always configure them, and you can have more of them. But this is like the baked-in metrics that Captain already provides without you having to do anything. So I've already built some predefined dashboards for this application, and if there's a new project I want to onboard, or there's this new service in this project, I just execute the script again, and that's it. So that's a very basic but very simple and powerful solution. And now I want to show you how it actually works behind the scenes. So we have this, and we just continue what Captain is and how we can configure your ecosystem. So I said it, already, Captain is an event-based control plane for continuous delivery and automated operations. So that lives in your Kubernetes cluster, or it can also live on some smaller Kubernetes distributions like Keys, K3S. It's also a great contribution. It just needs some kind of orchestration since it consists of a couple of microservices. So it lives as a control plane and will listen for events and will send these events to other services that are integrated. And it has kind of a predefined workflow based on best practices that we've seen. So it will, when Captain receives the information to deploy a new version of a microservice, it will start to deploy this, will send out these events to the deploying service. It will afterwards trigger the test integrations. Afterwards, it will trigger the evaluation of the tests. And afterwards, it will decide if it should move on to the next stage, let's say from dev to pre-prod, or if it should be rolled back. And it has built-in capabilities for different deployment strategies, different testing strategies. And of course, since we need some data to evaluate, I said after the tests, Captain will trigger the evaluation phase. We also need some data providers, and this is most often some monitoring solution. And since we need this data in a structured way, we built the support to also configure the monitoring solution so that Captain will configure the monitoring solution and in turn can retrieve the right data in the right format from the solutions. So from a conceptual point of view, the Captain control plane living in your Kubernetes cluster, it's configured via two files, basically. The first one is a shipyard file that defines the different stages. So it defines your project, how many stages do you have, let's say dev, pre-prod, and production, which tests you want to execute, which deployment strategy you want to apply. This is all defined in the shipyard file. And the other file is the uniform, the Captain's uniform. I'm not an English native speaker, but Captain should be like pronounced like Captain, the captain of a ship. So we are using the Captain's uniform. Our UI is called the Captain's bridge. We have a shipyard file. So all these terms come from the idea that it's the captain and the captain ships your applications. So we have this, in the Captain's uniform, we define which services to use. And we have a couple of baked-in services, and we have already a quite nice ecosystem of service of integrations to Captain. So for example, we have a GitOps integration not only with GitHub or GitLab, but also Bitbucket and others. We have integrations with the container registry, so Captain can fetch the containers, for example, from Docker Hub and deploy them. Integrations, if you don't want to use the Captain built-in capability for deploying, that's based on Helm charts. But if you want to use Jenkins, you can also use Jenkins or others. For tests, we have a couple of different integrations, so you can reach out and trigger the tests. Then for the evaluation, we have a built-in service which is called the Lighthouse that is using all those SLO files that are also used for configuring Prometheus and Grafana and these other tools. And then we have integrations for observability and dashboarding. So, and even more JetOps, you can see everything that's going on inside Captain. You can have it in your Slack or Microsoft Teams. You can even control Captain control plane from Slack if you want. So all this together, it will basically set up everything in your Kubernetes cluster for you, all the different namespaces for the different stages you have, but also the monitoring and dashboarding solution, for example. So I was talking about that we are configuring this, and I don't want to say everything's automated, or it's automated, but it's not automatically done and magically. So of course we need some input data. And we thought basing this on SRE best practices makes a lot of sense, because these are practices that can be reused quite a bit. And these are also the right level of abstraction and can be used for different personas, let's say. So, and there are three important concepts. I will only touch the first two here. The first one is service level indicator. Basically a metric. We can think of this as a metric, something like the error rate of login requests. And with this, we just get one we get a value. It's a metric you can think of. And upon the service level indicators, we can have service level objectives. And these objectives, they are goals for our service level indicators. So something like the error rate of the Lagrange requests, this is our SLI, and we define a goal that must be less than 2%, and we can even say within the last 10 minutes. So we really have our SLOs defined with our SLIs, and we can define SLAs that are more than business level agreements, and we have a business level agreement for our SLOs. And Captain already has built-in red metrics or built-in SLIs based on the red metrics, so you don't have to write PromQL if you want to use something. It has already built-in capabilities, but if you want to extend it, you basically write some PromQL and map it to an SLI. How you can do that? It's a one YAML file, which is our SLI file, and it's a mapping between the name of the indicator and then how to get it. It's the PromQL, for example. Or if you're switching from one monitoring solution to the other, maybe it's an API call. It's some query how to find the error rate. So in this case, this is our SLI file. And we also have an SLO file, which is again a YAML file. And we then define some objectives upon our SLI files. The beauty here is in the SLO file, it's completely abstracted where the data is coming from. So we don't have any API calls here, switch from one tool to the other. Totally fine, you just have to exchange the SLI file here. If it's already supported by Captain, then you don't even have to write this by yourself, but you just exchange the data provider, and you can keep the same SLO files. The other beautiful part of this SLO file is that I think it's very easy to read. It's very understandable. So in this case, the error rate is expected to be a maximum of 1. So it has to be smaller or equal to 1 for a full pass of this criteria. We can also have something relative, like it's only allowed to be increased by a maximum of 2%, or it has to stay lower than 10, or you can combine it, and you can have not only pass, but also warning criteria. If you're not inside the pass criteria, but inside the warning, Captain will give you half the score for this SLI. And with this, you can write your SLO file, and that's can be seen as a quality gate for continuous delivery. But not only as the quality gate for continuous delivery, but also as the alerting configuration for Prometheus, or some alert thresholds in your Grafana dashboards. So it's a lot of different things you can do, but everything's based on the same file. And we have 2 files that hold all the information that we need for those use cases. How is this used? I've shown you this commands with Captain configure monitoring and the tool. It will be sent to the Captain control plane. It will be distributed to all these different services. In my case, I have a Grafana service and Prometheus service attached. They will interpret this cloud event that they are receiving and do their API calls to configure those different tools. So basically, the Grafana integration does some API calls to the Grafana installation and provides the JSON to generate the dashboards. And for Prometheus, a couple of YAML files are generated and applied so that the Prometheus configuration is done. And as said, we can also reuse those files for something like quality gates in CI/CD pipelines or more CD pipelines. It's the same SLI file, it's the same SLO file, and we can use them whenever we do after some testing, or even in production, if we want to know about if our service is actually fulfilling our service level objectives. And we can start and trigger an evaluation for 30 minutes, for 1 hour, or just for the tests that have been executed, for a testing time frame. Captain will then reach out to all these different SLI providers. As I said, it's the data sources, might be Prometheus, might be Neoload, JMeter, for example, is also providing a lot of tests during a lot of metrics for the test execution or Dynatrace, whatever tools you have connected, will reach out, collect all the data for you, will then score each SLI individually, but also will generate a total score. And based on the total score, Captain will come up with a thumbs up or thumbs down, basically, and will inform you, but also give you all the details, of course. And based on this, you can then, for example, roll it back or promote it to the next stage. Or if the quality gate is triggered in after some kind of, let's say, remediation action, if something was going wrong and you triggered some counter action for this, then you can also use the quality gates to check, did this automatic action actually resolve the issue? And everything is based on this SLO file. So configuration, but also the automation is based on this. So how can you set up Captain for configuring your environments? Basically, you use the Captain CLI and create a project. The project is something, we can think of this like the application. And we just define this shipyard file. Let's say we define which deployment strategies, which test strategies we want to apply. And we put this in, Captain will put it into its internal Git repository to manage it there. So we'll create, in this case, a staging and production environment. So we want to onboard some services. So we just use the help charts. We use some help charts. If you don't want to have the continuous delivery part managed by Captain, then there is no need to use any help charts. But you onboard the services to Captain, so Captain knows how to manage them. So with this, you have your services managed by Captain, and then you add also your SLO and SLI files, so Captain knows how to configure other services. With this, and this can be added to the project level or also the service level. So you put in those files, and then you configure your monitoring solutions like Prometheus. And if you have the Grafana integration also installed, you will also reach out to Grafana and install this, and we'll come up with the scrape jobs, with the dashboards, with these kind of things. If you want to have them completely changed, then you can always change the Grafana and Prometheus services. Everything's open source here, and then you can just do it the way you want it. And then you can use Captain for automated, or let's say automated checks of the quality of your services with automated quality gates in your CD pipeline. And this CD pipeline can be done completely by Captain, or it can be orchestrated by Captain by integrating different tools like having Jenkins for you to deploy, or using Helm to deploy, or using Spinnaker to deploy. And then Captain might do the deployment in a, let's say, a blue-green manner that's defined. If it's blue-green or direct, or the deployment strategy is defined in the shipyard file. Captain will reach out to the testing tool, will execute the tests, and after the tests, Captain will do the evaluation. And the evaluation will be done exactly for the testing time frame, since Captain was orchestrating this. So Captain knows when the tests have been started, when it was finished, when they were finished. We will evaluate this and will come up with a score of this run. And the score can not only be all these metrics that you get from JMeter anyway, but you can use everything that's also collected by your environment or your data provider. So you can also use something like node metrics, CPU saturation, these kind of things that you might not get from the JMeter execution itself. And then Captain can calculate the score, and it can be promoted to the next stage or not. It can even be sent each promotion of the service. You might want to send it also to Slack, or if there is some, if the score is worse than the previous runs, then you might maybe want to add this information to Slack and then trigger the right teams so that they can take action immediately. If it's promoted, it's again the completely same workflow. If you don't have any tests defined, because maybe you're running in production and you don't want some artificial tests because you have your end users basically doing the then you just don't add any testing files. So Captain will skip this stage, but everything is already, let's say, predefined, and just by adding this configuration, Captain will trigger the different tools. So it will already, again, come up with a score. And if you want to add some more stages, like a security stage or a penetration testing stage, or whatever stages you might want to have. I was just talking today with the developers of Litmus. It's a chaos engineering engine, let's say, and they are also thinking of kind of using a chaos phase before production, so that they can just test how resilient their application actually is, or not their application, but the application under test. So you can think of this of all these kind of things. So how can we actually integrate with Captain? Captain is as said, is more a control plane and has a couple of functionalities baked in, but it has an ecosystem, and all these integrations to different data providers, they are part of the ecosystem. So they are part of the Captain contributions, and we have basically 2 or 3 different integrations for each of those use cases. So in this case, the Prometheus service is really something that is responsible for configuring Prometheus. If you don't want to configure Prometheus with Captain, you can just use the Prometheus SLI service. That's fetching all the metrics and transforming them into SLIs. And then we have this Grafana service. I was also talking, and that's also just connected to the Captain control plane. Now we're already coming to the resources I was mentioning before. So again, I've linked here the blog if you're interested, and I've linked a couple of code generators. So if you want to take a look at them, if you have more code generators that you are using that are not listed here, I'm happy to include them in this list, or if you don't want to have them included, but just shoot me a message if I should take a look at them, or if you think they are great. And then also the red method I was talking about earlier, I've linked it here. So with this, I think I'm already more or less at the end of my presentation. So if you think Captain is something that might help you, as said, it's not only for configuring Prometheus and Grafana, you can also use it for continuous delivery and automated operations. That's actually what it was built for. The other thing was just very helpful for organizations that started to use Captain. It's an open source tool. It's captain.sh. That's our website. We have a couple of tutorials there. We have documentation there. So if you want to just give it a try, it's tutorials.captain.sh. That's like a very, it's a catalog of different tutorials you can walk through. And if you want to join the Captain community, we have community meetings, all these kind of things. You're most welcome. Actually, right now, we also are part of the Hacktoberfest. I'm not sure if you've heard of it. Hacktoberfest, it's an initiative started by DigitalOcean. We are not affiliated with it by any means, but if you're contributing to 4 different open source projects during the month of October, and are linking your GitHub account to this Hacktoberfest platform, then you can receive a T-shirt or something like this. So we are also happy to receive any contributions. If you think, if you find a typo, it's already fine. If you do this contribution, if you want to contribute with more, like integrating some services, like Litmus is doing into Captain, then that's also great. So we are pretty happy to see this community growing. And with this, that was it from my side. Thank you so much. I'm happy to answer some questions. Yeah, thank you.
Okay. Thank you, Jürgen. Is there any questions from our end? Okay.
Doesn't look like we've had any comments in the YouTube chat. So if people, we'll give folks a few minutes just in case they're still thinking of some questions. Captain is obviously a really comprehensive and relatively complicated piece of software, I guess, given how much it's doing. So it's giving folks lots of food for thought, I'm sure.
Actually, what I should first say, and I apologize for not doing it before, was thank you very much, Jürgen, and
Thank you.
also nice Kurt Weill poster.
Yeah, thank you. I got it in San Francisco. After the show, they gave it away for free. So it was not for free. It was included in the ticket price, but
Okay.
it was actually this very concert. Yeah.
Excellent. One thing I would like to say, and it follows on from exactly what you were saying, is this is the start of Hacktober, which is DigitalOcean's. It's like a month-long festival supporting open source, sponsored by DigitalOcean. And the idea, as you said, is that if you do 4 PRs, then to various projects, you will get a free T-shirt. I don't know how many of you follow Twitter and Hacker News. They did get a bit of pushback today because various maintainers were complaining they get spam commits. But in the last hour or couple of hours, DigitalOcean actually put out a blog post trying to address some of those concerns, which I thought was a very good attempt. And it shows that they are trying to do it for open source rather than just purely promotional reasons, which I thought was really nice. And I did want to say, from my own perspective, I work for Container Solutions, and we have a bunch of open source projects that I really would be great if we can get any contributions to. So if you're interested, you can also go and take a look at those. I'm not quite sure what the deal is with links, but I'll try and figure out how we give you all a link and you can take a look at some of our projects.
Just paste it in the comments. We can bring them up.
In YouTube, you mean? Or
either. They're both linked.
Okay. So we have I should thank Nick actually for organizing this, and he uses quite an impressive platform. I think we can,
just trying to get with the times.
Sorry? Keep it up with the times.
Just trying to get with the times. Yeah, it is.
No, but thank you very much for doing all the backstage work. Okay, we are a bit ahead of time, but I think we should just crack on. And so the next talk, unless there's any question, there was no questions, right?
So I had one quick question, and that was, so there's a lot of during that presentation, a lot of talk of SLOs, SLIs, general SRE best practices and concepts, of which I'm a huge fan. But lots of people who might be included in the ideal target audience for Captain. What if they don't have any kind of prior knowledge or experience of that kind of terminology? Is it still a good fit for them? Does your documentation kind of ease them into some of these subject areas?
Yeah. So what we are trying to do is actually, we're also trying to bridge this gap by, if you already have some dashboards, if you already have some configurations, we are working on this by using this and then deriving some SLIs and SLOs from this, so that it might be easier for you to use it if you don't have it yet. And what we found out in the very first beginning, when people were using SLIs and SLOs, then sometimes it's not obvious what is the actual quality of my service. Because you're running the microservice, but you don't know how much memory it is actually consuming all the time, and what is like a normal level of memory and what is not, or the same with CPU saturation. You just assume it's working, and if it's not working, you restart it, but it's not very obvious. Then you throw some monitoring on it, that you gather the data. What you can also do is just use some relative thresholds in the beginning. So just define, in the next iteration, it has to stay within the boundaries of plus minus 10%. That already gives you the indication if the refactoring was a little bit too good, or if it was not good at all. But staying within these boundaries already gives you an indication. And that was already helping a lot of folks that were using Captain to just get a feeling for it. And once you then really know what the service level quality should be, or the objective should be, then you define an absolute threshold. But starting with something relative did help a lot in the beginning.
Cool. Makes sense. Thanks.
Oh, that's a good question. Thank you. Okay. Is there any more questions? Does anybody have any more anything else they'd like to add before the next talk? So, okay, I'm going to introduce Cameron Harper, who is going to be talking, and actually it segues quite nicely, I believe, because it's GitOps.
Perfect setup.
Yeah. So more GitOps, and I don't want to give it away, so I was going to mention Terraform and yeah, GitOps. So I'm just rambling now.
It's fine, Adrian. I'll just skip the first slide. Thanks for that, mate. You can't take a minute.
I did have it written down, the title of your talk, so I was going to introduce it, but I fluffed it now anyway. So, okay, thank you very much, Cameron. I'll let you take it away.
All right, thanks a lot, Adrian, and thanks again, Jürgen. That was a very, very good presentation. I've learned a whole lot about monitoring Kubernetes. So, as Adrian has just alluded to, this is an introduction to GitOps. My name is Cameron Harper. You can find me on Twitter and LinkedIn at CMHRPR there, and pretty much everything else, GitHub, Bitbucket, all using the same URL. So we're going to be looking tonight at deploying a function-based API to the cloud using Terraform and GitOps. So as I said, my name is Cameron Harper. I am a DevOps consultant at a company called ECS. We're based out of the UK. We're an award-winning digital transformation consultancy. And this isn't a sales pitch at all, so I'm just going to get the company spiel out of the way, as I just wanted to explain why I'm using the slides. I am extremely lazy, and so just can't figure out PowerPoint, so I just nicked the company deck. And anyway, just to kick off, so you might be asking now, GitOps, we've just heard about that. So thank you very much, Jürgen, for actually featuring and bridging on to my presentation tonight by mentioning GitOps before. So GitOps is a way of moving operations to be sort of orchestrated and leveraged around Git processes. So I did actually have an introduction slide here which had an agenda on it, but I've accidentally replaced it with the Spider-Man meme. So I'm just going to kick off by going into Git first, and then we'll start talking about what GitOps is. So I'm sure everyone watching is aware of what Git is. So Git is a version control tool, or it is basically the version control tool. It's pretty much the most popular one that's in use in the world, I think. And it's a way of managing sort of change around mainly sort of text-focused repositories. So it's perfect for code. So you introduce changes to a repository through a commit, and commits go into branches. So you start off with a default master branch, you add in your commits, which would be a list of changes. And the branch is a current state, so what current commit it's at, and that's called a head. And what you can do is you can create a branch from your master branch, say a feature branch, and you can go and make your changes into that. And then after that, once you've made all your changes to your feature branch and you've gone and tested them, you can actually go and create what's called a merge from the feature branch back into master, and that's what's. So if you're treating your master branch as what's ready for release, you're then just saying that this code is ready to release. And we're going to touch a bit more later on about what merges are in a GitOps workflow and how actually powerful they are. So just to go into GitOps now, we're just going to talk first about sort of a standard application development and deployment sort of life cycle that we're just going to call CI ops, so continuous integration operations. Just sort of called CI ops because it's centric around a CI tool, which you see down the bottom there. We have this Jenkins icon, so we're going to be centric around Jenkins. So if you can imagine sort of the standard software development life cycle that's gearing up to release something to the cloud, what you'd have is a development team which would actually go and create the application, and the infrastructure team who go and say develop the infrastructure as code. And then you'd have an operations team which would coordinate the deployment of both the infrastructure and then the application to run on top of that. So you'd have three separate teams with three separate processes here, two of which are producing like a deployable artifact, one in the shape of the infrastructure as code, the other one in the shape of well, here we have a Java-based application, and then again an operational team or operations team which goes and actually deploys the infrastructure and then the application on top of that. Now, there's some issues with this where you have three teams effectively trying to do the same thing. So each one of them has their core functions. Obviously, the development team is there to produce an application. The infrastructure team there to produce the infrastructure and the infrastructure as code, and the operations team is to go and provision all of these things to make the application runnable. But they're all just trying to do the same thing of actually build and deploy an application so it can be accessed. There's some other pitfalls you can fall into here. Say if you're chunking together big releases where you have multiple development teams working on multiple applications, which an infrastructure team will then work on the infrastructure to deploy all of these applications. And then you have an operations team whose job is there to actually just coordinate, again, the deployment of the infrastructure and then all of these multiple applications on top. Well, in that big bang release, as it's called, a single application deployment failing could mean that your entire deployment actually has to be rolled back and it's marked as unsuccessful. So GitOps is actually about containing this all in the same place. So I'll put this on the second point here. So Git is a single source of truth. This should actually be right at the top of this slide. So Git, everything in GitOps is stored in Git and hopefully in the same repository. So I'll get to that in a bit later on, how we can actually go and implement our own workflows using Git and how we store application code, infrastructure code, everything within the same repository. But I'm just going to run through the concepts right now. So we have what's called a declaratively described system. So again, using Git, we always know what our system should look like because again, this is stored as code in a repo that has Git again, so you can revert back, you can track changes through branches and merges. We also perform our operations using Git, so we can trigger lifecycle events based on things that happen in a Git lifecycle. So we can have merge requests when people want to merge two branches, which could trigger review stages. And once a branch is then merged, we can actually trigger deployment. And we do this through a means of automation through a CI/CD tool. So this means that we have automatic processes to make our environment match our desired state, which is always stored in Git. And if we have a look at this lovely circle diagram, it's produced by Weaveworks, which are a sort of cloud-focused company. I think actually pioneered the sort of concept of GitOps around Kubernetes. So like I said before, we have a desired state here, which is stored in Git. And then we have the runtime state of our system here and the observable state. So we can compare these two and then we go push forward by actually getting our system into our desired state. So how do we go about actually adopting a GitOps workflow? Well, as I said before, first of all, we have to store everything in Git. So I mentioned having a declaratively described system. Infrastructure as code is one of the key things to achieving this. So I want to make sure that our infrastructure as code is stored within the same repository as our applications. So all the things we need to deploy our applications are stored there as well. We also want to keep our tests there. We want to have our CI/CD pipelines or our actual means of automation also stored as code within our repositories, because like a lot of CI/CD tools, they allow you to sort of configure jobs and pipelines using graphical user interfaces, but I'm sure you'll be aware that this doesn't really scale well. So the best thing to do here is similar to our infrastructure, just keep everything as code. So that's why CI/CD providers are core to actually adopting GitOps. And another thing that we can do as well using sort of Git is to model environments. So I'm sure everyone will be aware of the concept of having individual deployment environments available. So for example, you have your production environment, which is where your customers use your application, and you could then have a staging application, which you use to stage changes before they go live to production, and then a development environment as well. You can actually achieve all of this through GitOps using Git branches, which I'll cover off soon. So infrastructure as code, as I mentioned, is a very, very key tool in the GitOps workflow. So they can store the expected and desired states of an environment, and we can automate deployments to our environments to actually update them to match the described state based on what is stored in Git. And we'll be using HashiCorp's Terraform when we actually get to the demo of this later on, as that's my infrastructure tool of choice. There's other tools available. I've actually included CloudFormation here. If you're working with AWS, it's just an example of something else you could use in a GitOps workflow. Now, I mentioned environments before, so I'm just gonna again go back to my sort of use case I went through there. So we've got a master environment in this conceptual application. Okay, so we've got a master or production environment. We've got a staging environment, and we have a development environment. So within our master environment or a production environment, this is what is actually deployed and accessed by customers. We then have a staging environment, which is a place that we can test different new features together. And we have a development environment too. This one is just purely for testing individual feature branches. So we can actually introduce all of these by using Git branches. Now, how we'll do that, I'll actually give a bit of a demo later on of how you can do that using GitLab, but most Git providers like GitHub, Bitbucket, and GitLab all have the concept of protected branches. And what these basically mean is that it's a branch where you can only make changes to them through the means of pull requests. And pull requests obviously have their own approvals, which again, we're going to get to soon as a demonstration of how useful these are in the GitOps workflow. So by applying protection to branches in our Git provider, we can make sure that changes can only be introduced by using branches. So using our sort of branching model, which includes a master, staging, and development environment, we can also go ahead and create individual feature branches, and we can go and deploy from these feature branches to these environments using these set of rules. So the first one is that we can't directly commit to a environment branch, and this helps us to ensure that changes are tracked back to their source. So that gives a bit more audibility to using GitOps. So you should never merge two environments branches directly. Apart from the case of if you're creating a new environment branch from master. So say if you only had a single environment, which was master, you could then create a new test environment by branching off master. But usually what you want to do as part of your workflow is to merge individual feature branches directly to their environment that you're targeting, except when you're going into master, when you're going to close it off, and then you're just going to make sure the changes live there. You should also make sure that your feature branches are autonomous in the way that they can actually be automatically tested by themselves without having to be deployed to an environment. Now, we actually go about putting the operational side into GitOps by using CI/CD automation. Now, CI/CD is what's known as continuous integration and continuous delivery, and it's all about automating the steps that we usually do to make sure that the code that we're developing is ready to go to production or deployed. And we do this through automated testing, automated planning, and automated deployment as part of GitOps. So first of all, we'll run standard CI pipelines, which will go and test the quality of our code and make sure it's doing what we want it to do. The next part of that is whenever we create merge requests to environments, we'll create a plan of the changes that we're actually trying to perform to that target environment. And then after a merge request has been merged, we're actually going to go and trigger the continuous deployment, continuous delivery side of things by actually going and deploying directly to the environment that that branch represents. So you can see here that we're taking the sort of standard concepts of Git, which is branching and merging, and actually making them a lot more powerful for the use of CI/CD automation. We can also actually introduce a quite standard software development principle of releases using Git tags as well. So again, just a bit of Git 101. Git tags are just sort of labels that you create within Git, which point to a specific commit. And Git tags are immutable. So what they can do is actually give us a good sort of versioning system. I'll give you a bit of an example in the right of the repo that we'll be using a demo from tonight. You can have a release stage as well, which is implemented through CI/CD, which will go ahead and actually go and create this new tag based on whether a branch is merged to production successfully. So how are we going to go about with implementing a GitOps sort of workflow with Terraform and GitLab tonight? Well, first of all, we need to start with an application. So I have put together a quite simple to-do list application, which is built purely for a demonstration. You can see a bit of the user interface here. It's got very, very simple functionality. You can add a new item, which goes into the to-do list. You can mark an item as in progress and then go add it to the list as already completed once it's gone and been finished. And it works by using some AWS services. So AWS public cloud provider. It's an application which runs on a set of Lambdas. So Lambdas are serverless function-based services. So you can just sort of chuck in some code and run that without having to think about the infrastructure. This is put into an API using API Gateway, so it can actually be accessed through a REST API. And then we use the S3 simple storage service at the end to deploy our front end. So that's actually developed with HTML and JavaScript. So it runs in your browser and then communicates directly with the API, which then sends requests on to AWS Lambda, which actually runs the application. And if you want to have a look at the sort of request structure here, you can see that we will get our static content from S3, and then any dynamic requests are served through to an API gateway through a Lambda function. And there's a DynamoDB database as well that we're actually going to use to store the state of the to-do list. And all of this code and all the CI/CD jobs that I'll be using tonight, as well as some hands-on tutorials that actually have to go and utilize these yourself, are on a public GitHub repo, which I'll share at the end. So if people want to go and have a look at that, you're more than welcome to. So we are going to deploy all of this using HashiCorp's Terraform, which is great for not only deploying infrastructure as code, but also applications as well. As I touched on before, we'll be using AWS Lambda. So this is purely Python based. So Terraform can handle this really well. It can detect any drifts in the state. So it makes sure that sort of the state of the actually deployed infrastructure and applications match what they should be. So that's good for actually detecting any drift, which is key in the GitOps workflow. And it can also be used to deploy static S3 content too. So I'm just going to go over some of the automation jobs we'll be using tonight as part of our GitOps workflow. Don't worry, I know everyone is sick of tables and slideshows and presentations by this point, so I'm going to actually go through these in a bit more detail when they're actually executing. But we got 4 jobs which are key to the workflow. So we got the first one, which is Terraform initialization, which will go and make sure that Terraform can read in the code base and make sure there's no huge syntax errors there, which would actually prevent it from running any of the plans. We also run some linting whenever a new commit is made, just to make sure that the code quality and syntax we're using is correct. And then once a merge request is created, we will go and run a Terraform plan, which will go and detect the current state of our deployed infrastructure and then compare that to a modeled state of the described state, which is stored in Git. And then once we have gone and applied the merge to the merge request, Terraform will go and trigger a deployment, which will then go and update the state to, again, what is what's desired based on the plan. So I am going to go and hop over now to GitLab, where I'm going to go and demo all these things. And here is a bit.ly link to the GitHub URL as well. So if you want to go and have a look at the code, you can grab this for yourself. Right, I'll just close PowerPoint now. So we have here the GitLab repo. If we go over to the branches, you can see before the concept of environments is introduced, we have a master branch here, which is our production environment, and we have a testing branch here, which is our testing environment. And we have made a branch earlier on, which I went just before the demonstration. And what I've done is I've introduced just a couple of changes here, which are purely syntax changes. So they won't actually affect anything within the Terraform code base. I'm going to go and create a merge request now to our testing environment. Now I'm using GitLab to do all this, and the CI/CD job files that are actually within the repo I'll provide are all just for GitLab, but this is very easy to achieve from the same sort of concepts through GitHub or Bitbucket, the CI/CD, or any other CI providers like Jenkins you want to use, or Circle CI. So if I go and now create a merge request here from our feature branch to our test branch again, so this is an environmental branch. What will happen when I go and create this? So I've got an issue associated with this that I created earlier on. So if we go and have a look at this issue, it is just describing what we're going to achieve in this change, and it's to remove a syntax warning within our Terraform code, which occurred earlier in a test deployment. So in the branch we have here, if I go and open it up, I can actually go and look at the changes that I've made between that and what's in the testing environment currently. So if we go and have a look at the changes, what I've done is I've simply just changed the syntax that was used within our Terraform code base from the deprecated 11 Terraform to Terraform 12 syntax. So it's not a big functional change at all. It's purely just to introduce one of the concept is purely to demo the merge request functionality here. So if I go and now create this merge request, what we can do is we can go on this page now, and we can see that a detached merge request pipeline is now being created. If we go in here, what we should be able to see is a couple of jobs running here. So the first one here is our linting Terraform, which is going ahead and checking the syntax which is used just to make sure there's no syntax errors. So linting is quite good because it can catch syntax errors, as in using deprecated syntaxes, but it can also catch incorrect syntaxes too. So we run this every time we create a new commit. And what this will do is it will just go and check very quickly that the Terraform code is, if it looks valid. It won't go and validate every single reference, but it just makes sure that it looks okay, which is a good quick test to run on our Terraform code. Now, GitLab CI works by running on a GitLab runner using Docker containers. So we're pulling down a Docker image of tflint now, so the Terraform linting tool which runs on our code base. So that's what's happening in this job. It does take a few minutes, or not a few minutes, a few seconds for the Docker machine executors to start off. So if I go over to the second job that's running now, we can see a planning infrastructure job here. So what this is doing is it's looking at the current state of our environment, and it's going to go and look at the desired state, which is described by Terraform, and it's going to go and create a plan of how to achieve that in the actual target environment once this actually starts up. Cool. So the tflinting job is now finished, and if we go back to the pipeline, we can see that no errors have produced because the test have passed here and the job is passed. And within our planning infrastructure job now, so this is going to take a wee bit of time because I have actually gone and torn down the environment before the demo, because I wanted to actually go and demonstrate deploying a full environment through this, as well as reporting back the Terraform logs of some changes back into our pull request. So once we're actually finished executing this pipeline, what we should see is a new section that popped up here, which will actually go and demonstrate the changes which are going to be performed when we approve our plan. So we see here now, we can say test summary contain no change results. Oops, that doesn't look right. Let's refresh that. Yeah, the test summary contain no change results, null. This is to do with the tflint, and tflint works by flagging incorrect code as a failed test. It doesn't mark correct code as a passed test, hence why we get a null result here. But the Terraform report itself, as we've gone and attached the plan from the CI job, you can actually go and see the changes here. So this actually makes merge request a really useful audit tool, because not only does it provide a quality gate, but it also provides a log of what's going to be changed. So if something gets released to an environment, at least the person who's approved it can go and highlight or sort of double check here. But hey, okay, these are being added, these are being changed, and these are being deleted. And if you go into the full log, you can see more details of this here. So this is all of our infrastructure here, which is going to be created. Now, as I said before, there's lots going on here, as this is technically an initial deployment. So we can go over here, and now that we've analyzed our plan, we can click our merge button. So this will go and trigger the Git operation of merging the two branches, which again will then go and trigger a CI/CD pipeline event, which goes and triggers our deployment pipeline. Now, if we go over here now, we can actually have a look at what's going on. So our deployment infrastructure job is just kicking off by preparing its environment within Docker. And as I'm sure everyone is aware, with Docker can take a few seconds to start up occasionally when you're using Docker machines. So what we're doing now is going ahead and executing the plan we previously created. So you can see all the events which are happening here. So we're creating all these individual resources, which were described in the individual plan before, which again has a audit trail going back to where this feature was created, what the purpose of it was, the means of a merge request, so who created the feature changes, and who went and approved them after checking this release log here. So it's not as a witch hunt, more as a very useful to figuring out the sort of decisions and thoughts that went into an issue if it should be occurred after being deployed through a merge request. But again, through the means of different environments or through the use of different environments, you should probably not actually have any issues actually reaching your master deployment environment or production, because you've already tested them in different environments. So what we can see now is that our deployment job has now completed, and just to go and prove this worked, I'm just going to go and refresh the pipeline. So if I now go over to the outputted URL from our deployment job, we should be able to go and jump onto our application. There we go. We've got our very simple to-do list here. So if we go and run this, so I should finish the demo. Hey, it works. And just as a sort of added bonus on environment management, so the test environment that we've been using for the sake of this demo is very short-lived in a way, but it should only be used to sort of test individual features. So we've gone and added another stage right here at the end to go and clean up after ourselves. So we have a destroy stage here, which will go down and tear down all of our Terraform and our application and our front end. So there we go. Yeah, we're just kicking off a Terraform destroy now. So just to recap on the demo, what we've done is we have taken an individual feature branch, which is here, made some changes, and we have gone and created a merge request to an environmental branch. We've reviewed the changes that are going to be performed as part of the merge request, which is always retained as part of our audit trail. So which has a log of planned changes, applied changes, the tests that were run before this, and who approved them and who made the changes, as well as the deployment logs. And we have automated all of this through the use of CI/CD. So I've actually just wrapped up a bit quicker than I would like to, so I'm just going to jump back to my slide for the URL for the code for this. So if anybody wants to pick this up themselves, they can. Oops, apologies there. That was I probably should have given a flashing light warning. I just jumped into that one again. So yeah, if you want to go to bit.ly/33 capital P capital R TQK, you can download all the code for this, so the Terraform, the application, as well as the GitLab CI/CD. And if you go and add that to a GitLab repository, then you should be able to try this all out for yourself. Yeah, thanks a lot for this.
Awesome. Thanks, Cameron. I'll just bring a few folks back in, and then we've got a selection of questions for you.
Oh, perfect.
So first up, Peter White asks if this is really GitOps. Weaveworks always bang on about GitOps versus CI/CD ops, the distinction being pull versus push, and I can never work out whether this is them banging the drum or common usage.
Okay, so this isn't purely GitOps. This is a Terraform sort of implementation that's very similar to GitOps. So as you're right, Weaveworks does go on about the push, the pull, and they do this through having a Kubernetes cluster, which then continuously pulls from a location. So this is a push-based approach. So you're very right to call this out. This isn't actual GitOps as run by Weaveworks. However, just like any other sort of DevOps-y style approach, it's meant to be picked up and adapted to what suits yourselves. So again, you can have GitOps concepts with push or pull, as long as it works for you, really. It's about sort of making processes that work for your individual teams.
Cool. There was a follow-on question to that as well, which is that if you have any comments that you might have about access control for Git repos. So preventing admin X is allowed to change this environment, admin Y is allowed to change that one, that kind of thing.
Yeah, this is where it gets complicated. This is purely based around your Git provider, so I'm not really sure what individual services do. I know for GitLab, once you use the on-prem, so the self-hosted edition, you can actually set up your own groups and then apply protections on branches at different group levels. But I think out of the box, it's basically you get sort of a couple levels of granularity. So you get maintainers and developers. So again, I think when you're looking at an enterprise sort of geared tool, you probably do have these things, but say for just GitHub and stuff like that, it's just you're limited to a few groups. So that is definitely an issue that you have.
But I guess, and this is there's another product that does something kind of similar to what you're talking about called KubeStack. That was actually an ex-CS guy that's developing. And I'm going to get this wrong, so I feel bad saying it. But you can split it up into different repos, right? So you could have your developers, whoever, pushing to one repo where things get tested, and then mirrored to another repo with different people having permissions. So that gives them then a chance to authorize PRs, etc.
Again, that's one of the beauty of using Git for GitOps. It's just reusing what someone's used to, and then you can use it in your own workflows. So again, if you're using that's totally a use case, but again, that's just using Git functionality, isn't it? So if you can mirror in between repos, that's a great solution.
And it also brings me on to, I guess my next question is, so one thing with your approach is, I guess if somebody goes and kubectl does something, things get into a weird state that you can't really, do you have a bit of an issue with different groups trying to do things to the same cluster And some people, because they don't know it's managed through Git, go in and try and do things via kubectl.
That's sort of what's the best thing about restricting everything to Git as the main deployment. So like using it as a single source of truth is that you shouldn't really be going configuring stuff like this anyway. Like all this stuff should be deployed through Git. And again, as we're using Terraform for short-lived environments, we should just be spun up on the fly for the sole purpose of testing something like this.
Mm-hmm.
So again, like you shouldn't really have any use case for going and tweaking this, because if you're going to be doing that, you might as well be doing it locally, making your changes and then committing that afterwards and then going to deploy that to an environment itself.
So are most of your deploys in the application or the Kubernetes YAML stage, are they done using Kustomize or?
So this is actually using Kubernetes for me at all. As the reason I wanted to use Terraform for this approach is because I'm definitely not Kubernetes savvy, so I didn't want to just be talking about something I didn't really know tonight. So
right. So this is more about setting up Kubernetes rather than the ongoing ops of Kubernetes, or what you're talking. Yeah, cool.
Well, less about Kubernetes and more just about taking a sort of different cloud native approach to something that was more geared towards Kubernetes originally.
No, that's excellent. Cool.
So there's a somewhat related question from Julian Grobelaar, which was that does GitOps or Terraform reconcile changes made out of band? So that's the same kind of thing. If you have somebody interacting directly, is it going to handle reconciling and making sure that the desired state of your deployment is where it should be? I'm guessing no. I think with this sort of thing, if you adopt GitOps or CI/CD ops, you have to make sure that's the ultimate gatekeeper for any change that you introduce into your environment. Otherwise, yeah, things are going to end up in an inconsistent state.
Well, I think that's. Oh, sorry.
On you, Adrian, if you want to jump in.
I was going to say, I think that's the point of tools like Weaveworks, Flux, and even KubeStat, perhaps, is that they become like, they're trying to keep everything in sync. So I believe Flux will be looking at Git, and we'll also be looking at what's going on in the cluster, a bit like Kubernetes does with its reconciliation loops and trying to keep everything in sync. So if somebody does go and change something, I believe Flux will say, no, actually Git says this and revert it. But I could be wrong. So perhaps I should stay quiet.
So like an implementation level, how you could achieve this with Terraform is to basically just have a scheduled repeated run of the apply. So again, that drift detection does exist like using Terraform, but there's no sort of TF diff tool like there is as part of Weaveworks agent that they originally used. So I think they had something called K8 diff, which you go and run as an agent and then with alert back as a CI alert to the teams. You go and say, okay, so the impact of this is we can no longer go and actually debug validly because the state has changed. So you could do that with Terraform, but again, you just have to go and configure the schedule to go do it for you.
Well, does that not run the risk of nuking the cluster?
It could do, but that's why you'd run as a plan, not as an apply.
Okay.
So yeah, always alert first and then decide, not just automatically brute force back the way you were.
Okay. Actually, cool. Cameron, have you tried Flux or any of the other tools?
Not yet, no, but I think I know what I'm going to be using over the weekend. I've been writing down everything that was mentioned from Jürgen and yourself so far as stuff to play with this weekend.
The other one's Argo CD, actually, because we've been using that a bit in container solutions. I think it's Argo CD, something like that.
It's also the one that we hear quite a lot, Argo CD.
Is any one of you guys using Prow? Just curious. Yeah, we use Prow.
That's
I feel like
P-R-O-W, I believe.
I'm definitely at my boat here is we're just using Docker and 3 Elastic Beanstalk stacks currently.
Yeah, I think it was actually a really good introduction to the sort of concept of, well, hang on, we can do this all through Git. And that gives us some nice advantages over the granularity of things and the control over what goes on. So I actually think it was a really good introduction like that.
Git strikes me as one of those things that's a bit like Vim. So you get used to like the Vim way of doing things or the Git way of doing things, and then you're like, I want to use Git everywhere. I want to use Vim everywhere.
What real alternative do you have to Git, to be fair?
CDS, SVN, Dart.
I remember using SVN to download Gary's mods when I was about 14. So
Nice.
that's showing my age right now.
Yeah, so there's a vouch for Flux from Peter White in the comments. Much prefer it over Argo. I'd bore you about it in the pub if there was a pub, indeed.
I think the pub still exists, we're just not allowed in it. I hope it still exists. Yeah. Nick, do we want to? I think there's a few other things we want to discuss about.
Yeah, there is indeed. So we were going to set aside some time today to discuss a bit about the format of future meetups. So we've been kicking around a few ideas within this meetup group, as well as other meetup groups that I'm involved in. So I also help to organise the Cloud Native Manchester meetup group. And yeah, you know, the virtual meetups, they kind of follow the same format, but obviously, you know, there's the elements of human interaction that's missing. And there's, you know, the conversations, the organic conversations that happen, all that kind of good stuff. So is there something that we can do as meetup organisers that are stuck in this virtual limbo to kind of fill that gap a little bit, to maybe do something a little bit different? And again, I'm looking to Alex here because I think he had some specific ideas, some really cool ideas about getting together, maybe selecting, you know, some specific projects or a common set of problems that we all share that we could work on together and, you know, design some solutions for and, you know, hack on some code, that kind of thing. So it's an open question, really. You know, obviously, we'd love to entertain ideas tonight, but by all means, get in touch with us. You know, we're on Slack, either the Kubernetes Slack or the CNCF Slack, anywhere really, with any ideas or comments or suggestions you've got, and we'll do our best to facilitate that.
Yeah, I don't know if anybody here has any suggestions. I mean, we could do things like even do something silly like a quiz or.
Just like an Ask Me Anything type thing, like a forum.
I mean, why don't we could do like we could have the questions and that like a pub quiz. So
that's a cool idea.
Join it and have teams would be a bit more interactive.
Are you volunteering, Adrian?
Possibly. Like I need ideas for rounds. I tell you what, if you come up with good ideas for rounds, I will.
Got it. Okay.
I suppose we should have somewhere where we collate these ideas. This is where my organisational skills
project or Pokemon. Or Greek word, I don't know. Or how do you actually pronounce these Greek words that are Kubernetes projects? Or Kubernetes?
So Kubernetes is like...
Oh, yeah, you've got an advantage here.
There you go. Yeah. Can be the smart ass in the room.
How do you? What's the correct pronunciation of Kubernetes?
Kubernetes.
Okay.
I'm not going to replicate that.
Yeah.
Cool. Okay, so some kind of quiz format would make for an interesting change. Any other suggestions? Like, what were your thoughts around like these workshops or hackathons, Alex? What were you thinking there?
So my thoughts are that, I mean, most of us work roughly in the same type of business, right? So surely the problems we're all trying to solve are pretty much the same, right? Like at least from a deployment or infrastructure point of view, right? Like the business value is different, but the delivering the software over to the customer is roughly the same, right? So I think it would be interesting to see if we're all trying to solve the same thing, then why are we all trying to solve the same thing? Why can't we just all come together and say, well, look, like we're all having issues managing a cluster, as an example. How are you guys solving it? How are we solving it? If we've written an operator and you've guys written something like a script, maybe we can somehow merge the two. Maybe we can get together over a weekend and, I don't know, knock it around. Like, that's kind of the thing I'm thinking. I know it's very abstract and doesn't help much, but that's the idea anyway. Like, I think a good example is secret management, right? Like, how do you do secret management in a GitOps world?
Yeah. I have to say my one reservation is everybody does the same thing slightly differently. And I think the classic example of this is CI/CD. It's like every company I've been to has their own CI/CD, and it's always a little bit different. And it's not different for bad reasons. It's different for very good reasons. So I think people do face different problems, but perhaps there's still enough similarity between them that they would benefit from, exactly what you're saying.
Yeah, like another good example, I think, is delivering the images in the cluster, right? Like, I don't know, container registries. Do you cache them locally? Do you pray key is online when you do the deployment and hope for the best? Or ECR or whatever is equivalent?
Yeah, that's a good point. Yeah, no, there definitely are things. You're right.
I think another good thing we could do is run like polls. Like, for example, how many people use, I don't know, Flux in production today, or GitLab, or Kubernetes, or Prometheus, or, And I think from there we can drive conversations, because if the majority of us are using, say, Prometheus, then, well, maybe it's a good topic to talk about, as an example again.
Yeah, sure.
So I suppose it's incumbent on us organisers to somehow collect this then, and then kind of organise some specific focus workshops on that stuff. So maybe if we send out something via Meetup or whatever, once we've agreed on how to gather whatever it is that people want to discuss, or whatever dirty laundry they want to air as far as cloud native goes, and then we can we can try and get something set up. That sounds really cool.
You could use what the teens are using these days on Twitter. Get one of those anonymous question asking websites. People can air their dirty laundry anonymously to you guys.
That sounds scary.
Yeah, I thought that's what Adrian meant by quiz. I thought some kind of just AMA thing where it's just a grab bag of like anonymous questions. We'll just leave it to Adrian to answer.
It might start getting a bit personal.
Yeah, I'm a bit more old school. I was thinking pub quiz.
Yeah, when you said like pub quiz, I was thinking like a therapy session where we all come together and just moan for all we faced the past week, and because we're drunk enough, we won't remember next day anyway, right? So,
well, that's actually something that came up at my work today, because I think some people are suffering from lockdown because they don't really have any good outlets to vent. I'm not sure, like the Kubernetes meetup. Well, I think it probably did. Like, there was a certain amount of like venting that went on there.
You're
so it would be good to allow that. Sorry?
You're signing up for quite a lot here, aren't you?
Well, to be honest, I'm signing up for anything that gets people involved and makes people feel a bit part of something again. That's what I'm signing up for.
Yeah, good.
But that's not an easy thing to achieve, and I don't really know how. If a pub quiz does it, yeah, do that, definitely. If I'm not sure and ask me anything, we'll achieve that though.
Are there any other platforms other than StreamYard that are more inclusive of the people who join, like be able to actually speak?
Yes, I mean, we could revert back to something like Zoom. There are other platforms as well. So the Edinburgh Linux user group uses Big Blue Button.
Okay.
StreamYard works pretty well for this kind of format where it's you just have like a sequence of presenters. It's great for that kind of thing. But yeah, it's not the best format if it needs to be a bit more interactive. So we could look at setting something else up.
I'm just wondering, like, if there's people that they're not commenting anything but would speak, and they could just click a button. And, yeah,
it's a good show. Jürgen, so you've recently started a new meetup in Linz. Have you got any cool ideas for your meetup group that we could steal in the spirit of community? Are you looking to anything interesting? Any interesting ideas for formats?
We were thinking about a lot if we should do an open Zoom room, basically, or just a Zoom invite where everyone can share the camera and share like the voice. Because I was invited once at a meetup that did it this way. And it only works if you distribute the Zoom links to all the registrants from meetup.com and not publicly. Otherwise, you have a lot of Zoom bombers, as we all know. So we also decided to go for this format with StreamYard and to have the presenters sharing, and then you have kind of the audience. But we also feel it's not as inclusive as it was before. But it's not that during the presentation you want you want everyone to interact. It's just like after the presentation. It's really and with StreamYard, although the YouTube integration is pretty fine. Yeah, what we did is we set up a Discord server, and we also had some questions in the Discord. It's for free. They have like community service, they call it. They have some additional features, but we are just building this community. So I know you have already this community built, which is great. We just started, so we are at the very beginning, but we had the same thoughts, and yeah, we are not yet sure what is the best approach.
I was going to say, Discord sounds like a really, really good way of getting people together too, because obviously you've got like a in and out chat room, and everyone's free just for like basic features for like a sort of more of an interactive community approach than sort of just a live stream.
Yeah, we're looking at as well.
Like Slack and Discord, and you have the YouTube chat, and everything is really distributed. So it's kind of a challenge until maybe the community itself can figure out.
Does anyone watching has any thoughts? Maybe post in the comments or something.
It's gonna be an awkward silence now.
Yeah, I mean, this is a perfect example of why it doesn't work too well for this kind of thing. Is you just sat there speaking into the ether, hoping that someone is going to answer. Maybe everyone's just sat there nodding and has no better ideas than we have. I think Cloud Native London, do they still use Zoom? And they used Zoom initially for their virtual meetups. So I think that was because they have crazy turnouts, like hundreds of people.
I think they're still using Zoom but then they have the chat option inside Zoom. I think they were allowing also the audience to interact, not with screen sharing, but yeah, with asking questions.
I see we're getting +1s for pub quiz. I think
seems like that's a winning idea.
Here.
Yeah, so Peter's agreeing. Definitely the casual chat in the pub is what I miss most as well. Yeah. So
in Zoom, I believe, yeah. So I've done like pub quizzes in Zoom before, and one of the nice things was you could have like team chat rooms. So like you'd pose the questions, and you could have teams, and teams would like go to their own chat room to discuss the questions, and then they come back to the main chat room. So we could do that. But that, to be honest, that's getting a bit complicated.
Yeah. Like Call of Duty.
Sorry? Call of Duty.
Call of Duty, yeah.
Well, I mean, Software Circus did do. The first one we had was right at the start of this, and we did do. Wasn't Call of Duty? I think it was. What's the Half-Life one based on the Half-Life engine that's really old? Counter-Strike.
Counter-Strike.
We did a Counter-Strike thing around the Software Circus conference, and I think that went quite well. I mean, I didn't take part because they had fun.
Is it? It's just above you, is it, Adrian?
I think I'm too slow. I think it'd be annihilated, and I feel bad. It actually
Counter-Strike is
seemed,
very much a skill-based game. Like,
yeah, it seemed very strategic as well. I did watch it briefly.
it's good fun once you know what you're doing, which I haven't known what I was doing for the past 7 years. So
I don't know what I've been doing for the past 39 years, but anyway.
once
Okay.
once COVID's gone, we can all get back on the Nintendo 64s and play GoldenEye if you want. If that's more your alley.
Thanks. It's more Doom, to be honest. Okay. Is there anything else? Nick, I'm looking at you.
I was just checking to see how many people were left viewing on YouTube. Well, no, if there's no further comments, I think we've got some good ideas to work with there already. I mean, obviously the quiz idea seems to be a winner and would make for a nice change of pace. So we'll look to do that for the next one, and we'll have to just investigate the best format for that. It sounds like it's going to be Zoom. So the best way of organising that, I guess, is take away homework for us organisers. I mean, yeah, in the meantime, just once again, if anyone's got any other ideas, if there's specific topics they want to see, even if it's just for like a regular meetup, so to speak, if there's a particular topic they want to see, then just get in touch. You know, we can try and reach out to the community. One of the best things about virtual meetups is that we can pull in pretty much anyone from anywhere. So again, you know, Jürgen tonight, a fantastic international speaker that otherwise might not have made it to Edinburgh. As fantastic a city as it is to visit, you know, logistics aren't always that straightforward. So yeah, I don't think there's any more to say on that really. Get in touch with any more ideas, and then watch this space, I suppose.
That's good.
Good stuff. In that case, thanks again to Cameron and Jürgen for giving us your time tonight. 2 really excellent talks. I certainly learned a lot.
Thanks for having us.
Cool.
Thank you.
In that case,
Have a good night.
cheers all. See you again soon.
Cheers.